In lesson 2.4, we're looking at some basic facts that deal with circles. And so to begin with, we have some terminology you need to be aware of. For example, the center of the circle and the distance from the center to a point on the circle is the radius. Two radii added together is the diameter. When you have the endpoints that lie on the circle. A line that goes through a circle in 2 points is called a secant line. A chord is a segment whose two endpoints lie on the circle. And then a tangent line is just a line that touches the circle in 1 point only. Let's see. The perimeter of a circle is the distance around, just like before with our polygon shapes, but in a circle we call it a circumference. So to find the circumference of a circle, we start at some point and we just measure around the circle. Okay, and to do that, our formula is 2 times pi times r. And pi is approximately 3.14. That's a measure that we use quite often to find the circumference. Another way to define the circumference, since 2 radii equal a diameter, you could say that this is also pi times diameter. Let's see if I can get it. So circumference could also be 3.14 or pi times diameter. And it depends on what they're asking for in a problem. If they ask for an exact answer, they're looking for an answer that has pi in it. If it's a decimal approximation, then you can use the 3.14 as an approximation. To determine the area of a circle, our formula now is pi times the radius squared. So it's pi r squared. So the example that they've got here for us is to find the area of a circle with a diameter of 1,254 feet. Okay, so here we have a circle. We know that this entire distance, let me see if I can highlight here. This distance here from point to point is 1,254 feet. And we're asked to find the area of the circle. So in order to do that, we're going to plug in what we know into this formula. So area is equal to pi times the radius squared. Now, 1,254 feet is not the radius, that's the diameter. So to find the radius from the center to a point on the circle, we're going to need to take half of that 1,254. So the radius here is 627 feet. So we're going to plug in 627 squared times pi. And when you multiply 627 times 627, we end up getting 393,129 pi. And that's our area, feet squared. Now circumference, it would just be feet, but this is area, so it's feet squared. Or if we made this replacement for pi as 3.14, our area would be 1,235,051 feet squared. And that's an approximation. Some other terms that we need to be aware of are arc, sector, segment, that sort of thing, central angle. A central angle is an angle whose vertex is at the center of the circle. So this angle AOB, is a central angle. And the measure of a central angle is going to be the same as the measure of its arc that's intercepted. Now, an inscribed angle is different. This angle, ABC, is an inscribed angle whose vertex lies on the circle, and its measure is half of the intercepted arc. So looking at these two here, if the arc were to measure, we'll say 50 degrees, then this angle here would be 50 degrees. That central angle would be the same. Whereas if the arc here measured 50 degrees, then this inscribed angle would only be 25 degrees. Okay, so it's half of whatever the arc is. Now the measure of a sector is an area. So it's a part of the area of the whole circle. So we'd have to use that pi r squared and then consider this a fraction of the whole circle. And a segment here is even more of a part. It's bounded by a chord and an arc. And here again, it's an area that we're looking at here for a segment. And one other thing we need to consider in looking at these circles and angles is a radian measure. Now, you probably have not used that very often in the past. We usually think of the angles that are formed in a circle. But the way we determine a radian is we start by, with our circle, we consider what a radius is, whatever that happens to be. If that's 3.72 centimeters, then that's the radius. We take that, and it's like we've cut a piece of string the same length and laid it out. That's 1 radian. That length of that arc there is 1 radian. So the central angle is equal to 1 radian. Now, we can change that to degrees. And if you'll notice here on the drawing on the right-hand side, when we consider going all the way around the circle with radian measure, we end up with this little part left over here at the end, this point 1.05 centimeters, which is that remaining amount here at this 0.14. That little piece that's left over is 0.28 radians because there are 2 pi or 6.28 radians in a circle. 2 pi is the complete measure all the way around, just like just like 360 degrees is a complete measure all the way around the circle. So in this problem, what we're looking at is pi radians equals 180 degrees. Now that's a fact. So if I have pi radians equal to 180 degrees, I can put pi radians over 180 degrees. And since these two things are equal, I'm going to use R here, stand for radian. Since these two things are equal, that's something divided by itself, which is another name for 1. Or we could use 180 degrees over pi radians. Well, if I'm trying to change 125 degrees to radians, I've got 125 degrees, and I want to do something to that. I want to multiply by some fraction here, so that when I get through multiplying, I end up with something in radian measurement. So many radians. Well, I've got to choose between one of these two facts here. Either I've got to use pi over 180 or 180 over pi. And what I'm going to choose to use is pi radians over 180. Because that's 180 degrees. And degrees divided by degrees, that's going to cancel out, right? So 125 divided by 180, that's going to give me, when we reduce this, we can divide both of these by 5. So we end up with 25 pi over 36 radians. And we were looking for that radians there. That's my little question mark, sorry. Anyway, I hope this helps.